A computer system is a fundamental and permeating part of modern life. It has revolutionized the way we work, communicate, learn, and entertain ourselves. A computer system is not just a single device, but a sophisticated combination of hardware and software components that work together to process information, solve problems, and execute a multitude of tasks. A computer is fundamentally a digital machine because it operates based on digital data and binary logic. A computer processes data digitally by converting input information into binary codes like zeros and ones, storing it in memory and utilizing its central processing unit CPU to execute a series of binary-based instructions. This digital approach enables computers to perform a wide range of tasks with incredible speed and accuracy. A digital computer is an electronic machine as it consists of millions of electronic switches. An electronic switch is very similar to a switch that is used to turn on and off lights at homes. The main difference is that it works on very low voltage. If the electronic switch is closed, electricity flows, and if it is open, electricity doesn't flow. So in short, the switches has only two states, on and off. Binary number systems used for counting also consist of two digits, zeros and ones. Therefore, binary digits 0 and 1 are used in computers to represent the two states of a switch. When current flows in a switch, it is on and represents binary 1. When there is no current in a switch, it is off and represents binary 0. So in short, a binary digit 0 or 1 is referred to as a bit. So groups of ones and zeros are used in computer to represent data, and this is known as binary code. For example, the binary code 10000100 may represent the letter D. A computer must be able to recognize codes that represents numbers, letters, and special characters. These codes are known as alphanumeric codes. Alphanumeric codes includes the following characters such as number 1, lowercase letters A to Z. Along with lowercase letters, it also supports uppercase letters from A to Z. Moreover, numeric digits from 0 to 9. In addition, it supports special characters including punctuation marks and special symbols such as 5, @ hash, plus, and percentage. The American Standard Code for Information Interchange, also known as ASCII, is the most commonly used alphanumeric code. It uses 7 bits or 8 bits to represent a character, and the total number of characters it represents is 128. So basically, there are two types of signals, analog signals and digital signals. So first, let's explore analog signals. Analog signals are continuous signals and are represented by a continuous waveform. Means analog signals are like waves that go up and down. They can be strong or weak, and they can change slowly or quickly. It's like the sound of your voice when you talk or sing. The sound goes up and down, and it can be loud or soft. Or it's like the light from a lamp that can be bright or dim. Audio cassettes. are a great example of analog signals. Think of an audio cassette like a recording of your voice or your favorite songs. When you play the cassettes, you hear the sound coming out of the speakers. But basically how it works, when you record your voice or a song onto the cassette, it creates a special kind of wave on the tape. This wave is like a picture of the sound. The wave is made up of ups and downs like a squiggly line. These ups and downs match the sound waves or your voice or the music. When you play the cassette, the tape reads this squiggly line and turn it back into sound waves. The sound waves comes out of the speakers and you hear your voice or the music. So basically, the audio cassette is like a special messenger that stores the sound waves as a squiggly line on the tape and then plays them back to you as sound. So in this way, analog signals is just like a continuous squiggly line that represents the sound. Another example of analog signals is analog video signals like VHS tapes. VHS stands for Video Home Systems. You might have seen old video cassettes at home such as VHS tapes that contains precious recordings of special moments like your parents' wedding ceremony. So these tapes basically hold cherished memories or capture in analog format and can be played back to relive those joyful moments. Basically, just like audio cassettes, VHS tapes store analog signals as squiggly lines on the tape. These squiggly lines represents the video and sound and are played back to you as a continuous signals. That's why when you fast forward or rewind a VHS tape, you see a blurry or squiggly picture. It's the analog signals being read and by the tape player. Human speech is another analog signal example. When we speak, our voices create sound waves that vary in pitch, volume, and tone. These sound waves are continuous and smooth, like a waveform, making speech an analog signal. Analog temperature reading is another excellent example of an analog signal. Think of a traditional mercury thermometer. The mercury level rises or falls smoothly, indicating the temperature, right? So the temperature reading is continuous with no breaks or gaps. The mercury level can be anywhere between the minimum and maximum marks, representing a continuous range of temperature. So basically this is an analog signal. Another example is analog voltage signals that are basically used in a wide range of applications like from audio and video processing to industrial controls and medical devices. So basically these are also analog signals because the signals can take on any value within a range and the signals changes smoothly over time without sudden jumps, and the signal is often proportional to the physical parameters like that are being measured. Analog watches are classic example of analog signals in everyday life. Basically, an analog watch displays time using hour and minute hands, as we all know, and move continuously around a circular face. The position of the hands represents the time, with each hand moving smoothly and continuously to indicate the hours and minutes. Radio signals are another excellent example of analog signals. Radio signals are a type of electromagnetic waves that transmits information wirelessly through the air. So basically, their continuous waveform and smooth variation makes them a great illustration of analog signals characteristics. Another very important example of analog signals is speakers. Speakers basically convert electrical signals into sound waves. So basically, next time when you are experiencing or listening music or a podcast through speakers, remember that you are experiencing analog signals in action. Another real-world example of analog signal is weight scale. Weight scale demonstrates analog signals because they measure weight continuously. So next time you step on a scale, so remember that you are experiencing an analog signal. This is all about analog signals. I tried my best to explain analog signals with multiple examples, and hopefully you grab the concept. So the next type of signals is digital signals. Digital signals are discrete, or you can say that non-continuous binary signals that represents information using a series of discrete values. These values are typically represented by zeros and ones, where 0 usually represents the absence of a signal or a low voltage. On the other hand, 1 represents the presence of a signal or a high voltage. Digital signals are commonly used in modern electronic devices and communication systems. Let's explore a few examples of digital signals. So the first example of digital signals is your MP3 files. So first let's talk about sound waves. When a sound is made, it creates a wave that our ears pick up. To reduce that sound, we need to convert it into an electronical signal. This is where analog to digital conversion comes in. The sound wave is sampled thousands of times per second, and each sample is assigned a digital value. This creates a digital audio signal. But raw digital audio signals are huge. To keep them manageable, we use different compression algorithms like MP3. So these algorithm reduces the file size by discarding some of the data. So this is, I think, the best example of digital signals. The other example is of images. Like when we take picture with our phones or cameras, the resulting image is made up of tiny dots that we call pixels, right? Each pixel can be either black, white, or a specific color. Think of each pixel as a light switch that can be turned on, it means 1 bit, or it can be off, like 0 bit. So when we combine million of these tiny on and off switches, we get a digital image, right? In other words, you can say that a digital image is made up of a series of discrete values, zeros and ones, that tell the computer or phone what color each pixel should be. Example of digital signals is digital videos, right? MP4. Basically, digital video signals are a type of digital signals that represents a sequence of images or frames displayed in a rapid succession to create the illusion of motion. Basically, digital videos consist of a series of digital images that we call frames, and that are displayed in a rapid succession, like 30 frames per second, right? And each frame is made up of pixels represented by digital values like zeros and ones. So the digital values are transmitted or stored as a binary signals, a series of zeros and ones, and these binary signals is decoded and displayed on a screen, creating the illusion of motion. Another best example of digital signals is your mobile phones, your smartphones. Basically, you make different calls through your mobile phones in which digital audio signals transmits your voice to the recipient phone, right? And you use your cameras to capture digital images and videos, right? And other than that, you use internet connectivity in which digital data signals transmits and receive data for your browsing, emails and apps. In your phone you use Bluetooth and Wi-Fi. Basically, digital data signals connect your phone to other devices and networks. In the same way, you use touch screen on your mobiles. So the digital control signals detect and respond to your touch inputs. So in this way, this is, I think, the best example of digital signals. Another example is smartwatches. Smartwatches basically track fitness and health data. That is just because of your digital data signals. And again, it displays notification and information. It's just because of your digital image and text signals, right? And then in some watches you can play music and you can connect to phones and Wi-Fi. This is all just because of the digital data signals, and it can monitor your heart rate and other vital signs. Like, it's again just because of your digital sensor signals. Digital number clock uses digital signals to show the time in a numeric format, making it easy to read and tell the time. Basically, a digital number clock displays the time using digital signals represented by numeric displays such as LED displays and LCD displays. These displays shows the time in numeric format, like using digital signals to display hours and minutes and display seconds and indicate AM and PM or 24 hours. This is all about the analog signals and digital signals and the key features, or you can say that the differences between the analog signals and digital signals. Now this is the time which is called test time. I'm going to ask a few questions and you have to answer it, and just check your knowledge, what you acquire from this video. Question number 1. What is a digital computer? Question number 2. What is an electronic switch? Question number 3. Why the binary digits used in digital computers? Question number 4. How many states a switch has? Question number 5. When current flows in a switch, it is on. We know that. It represents binary number 0 or 1. What is alphanumeric code? Write 8 differences between analog and digital signals. This is all about today's lecture. Thank you so much.